Hello, so today I'm going to give you an introduction to starting to work with VisiCal on the Enki server using an example calculating saturation pressures for melt inclusions. So the first thing you're going to want to do is start a browser tab. I'm just going to do this in incognito so it doesn't remember me. So first you're going to want to navigate to the Enki portal. So if you type in Enki portal, you'll end up at this website. And then you want to go to where it says Enki server and say go to the production server. And you'll get to this page. And the first thing you really need to do, if you don't already have a GitLab account, is to make a GitLab account. So you can just go to GitLab. And it'll just take a few seconds. And then it says if you don't have an account, register here. So you can do that. And you can register with sort of all your standard registration things. So once you have your GitLab login, you click sign in with GitLab, and then you're gonna log in, and then press the sign in button. So generally the server can take sort of a few seconds to a few minutes. It's super quick today to warm up. It might take a little bit longer than that for you. And you'll start at this home screen, which explains a little bit about the Enki server and has some links to sort of useful documentation. So in this case, we're just going to say close this screen. And then you end up in your own sort of personal server space. So you can see you have a folder structure on the left-hand side. So if you click the actual folder button, you'll end up sort of at your file structure. And yours will be pretty empty, but you can make a new folder just by pressing this new folder button. So for example, I would just type YouTube examples 3 as I've done this a few times, and you can see you've got this new folder now. So then you can double click and you'll want to start by making a new notebook. So for example, in this case you want a Python 3 notebook. So it starts out like this, and you just have an empty cell, and you can sort of type any code into this. You can add new cells at the top here with this plus button. You can change the cell type. So at the moment this is a code cell. But you can change it to a markdown cell, which allows you to write like comments. You can say this is a cell with, I can't type, useful text. And then on Windows, you can just press Shift Enter. Now I'm going to show you starting with a notebook that I've already made and that you can download, just so that I'm not making so many typing errors. You can just close these notebooks at the top and no, I don't want to keep this. So first of all, I am going to load in from my computer. So we're using this sort of upload button, and I have put the things I need for today in my downloads. So I have a Jupyter notebook, which ends with this IPYMB extension, as well as a Excel file, which has melt inclusion data in from Mike Cassidy's paper. So we open those up, and you can see now they have appeared in your file structure. So just as a bit of an introduction to what that Excel notebook looks like. So at the sort of first column, we have a label, which is the sample name. I then have another column for the phase. This doesn't matter, VisiCal isn't going to use this. And then I have all the oxide concentrations in the melt inclusions. These columns can be in any order as long as they have the right column headings. And then over here, we have the water concentration in weight percent, the CO2 concentration also in weight percent, and the temperature in Celsius that I want to run my calculations at. So first thing I'm going to do is open up this Python notebook, and then I'm going to talk you through the various cells. So the very first thing you're going to want to do is install VisiCal through pip. Now on my computer, it's going to say that it's already installed, but on yours, the first time you do this, it'll take a little bit longer just to download it all. And then the next cell, what we're going to do is import VisiCal as V. And this means anytime we want to call the functions from VisiCal, we can just use v dot. So it just makes it a bit shorter. Now for running, you can either press this run button at the top, or I'm just using Shift Enter on my Windows PC. And then this next cell down, this is just going to import various useful Python things. So we're going to import matplotlib as PLT, and this is how we're going to make some plots in the second half of the tutorial. And just because it might be useful when you start Googling various other Python things, we're just going to import pandas as PD, and this is Python's way of like having nice data tables way of laying out data. And we're also going to import NumPy, which does Python's like math operations. So we're just going to run that again, Shift Enter. And then this is sort of the first vCal cell. So we're using vCal's batch file function. So we give it the name of our Excel file. And if you haven't got that, or it's really long, what you can do is you can just click here and right click and say rename. And then you can just copy and paste it in. So that's what I generally do with a long file name. And then you're going to tell it the sheet name that stuff is stored in. So in this case, it's sheet 1. And this is sort of just like the default, but it's in weight %, my data. So we're going to load that in. And then you're probably going to want to inspect your data before you do anything with this. And this is basically just checking that it's read in correctly. For example, some supplements, the zeros in like SiO2, there might be a 0 rather than an O, or maybe some columns have like weird characters in. So generally we just take, we've saved this data in this thing called myfile. So we're just going to do myfile.getData. And then you can see it displays it nicely as this sort of table format, and you can just look along. And you can see in this case for chromium, nickel, cobalt, and phosphorus, I didn't give it any concentrations. So it has just filled those in with zeros. So now this cell is sort of doing the calculation. So in this case, we're calculating saturation pressures for these melt inclusions using the default vCal model, which is MagmaSat. And here I'm specifying that I want the calculations to be performed at the temperature stated in the column temp. So you can see here I have this column temp with 1050 in. If you wanted to run them all at the same temperature, like this column could vary, you can just type in a value here. So it's quite easy to adapt. So again, press Shift Enter, and you can see MagmaSat takes about a second per calculation. So Kayla's just built this awesome status bar, so you can see when it's finished. So we're finished now. If we want to look at what this sort of thing looks like, we can put it into a new cell and press Shift Enter. And you can see this is now your data table that you sort of entered, and these new columns have been appended on. So we have the saturation pressure in bars, we have the proportion of water in the fluid, the proportion of CO2 in the fluid, as well as sort of the mass of the fluid at saturation. It tells you the model you've calculated at, and if you've entered, say, a composition which exceeds like the range of the calibration data set for certain models, it might be that we have printed warnings in this column here. In this case, they're empty. So I'm just going to get rid of this cell to tidy it up using the scissors, so you can kill that. And to extract like a single column from this Panda data frame, what you do is you use square brackets and then sort of the quote marks, and you just put the column heading name. So in this case, I am just extracting the saturation pressures. Just ignore these warnings, that they're not important. Okay, so that's calculated using MagmaSat. But say I want to calculate saturation pressures using a different model. So for any model other than MagmaSat, you need to specify the model name. So you can see here, we're saying, again, myfile, calculate saturation pressure, run the calculations at the temperature in the temperature column, and use the model Iacono-Marziano. And you can see you can run that. And if, say, you type the model name wrong by accident, I'm just going to show you what happens, you'll get this error message, and if you scroll to the bottom, it says the model name given is not recognized. Run the method model names to find the allowed name. So I'm just going to copy that, put that in a new cell, do v.getModelNames, and here you can see these are all the names for the different models. So you can just simply copy and paste these out if you can't remember them, and put them into that previous calculation. So let's run this again properly, just so that it's stored. And then again here, we're going to calculate saturation pressure, this time using volatile calc basalt, which we've called Dixon in here, sort of for shortening. So you can see run that, it runs very quickly. So then I'm just going to show you some like quick ways you can plot your data, and there's obviously tons of ways you can plot your data, and I really recommend watching some YouTube tutorials on Matplotlib if you haven't used Python before. So this is just one of those markdown cells again, so it shows the text. So the first line is saying, let's set up a figure, where we have two different subplots, and we're going to have them laid out so it's like 2 side by side, and then a total figure size of 12 and 5. And then the first line, we're going to plot from our saturation pressure magmasat data frame, the saturation pressure in bars against the saturation pressure in bars from Dixon. And then I'm also have added a 1-to-1 line just to compare here. And then setting up the X label and the Y label here. You can see you can run that. And then on the second plot, I want to plot, say, the water content of my melt inclusions versus the saturation pressure from magmasat. And again, you can see you've got the X and Y label. And in this case, you can see that the axes are overlapping. You know, this sometimes happens. So anything you get stuck in Python, I would just recommend you Google. So we can say subplots, overlapping axes. And someone will always have had your problem before. So you can see, just add the following. So I can copy and paste this out and put it in here. And ta-da, my axes are no longer overlapping. So Stack Exchange is very much your friend. It's pretty much the first thing that will come up when you Google anything. Say I want to plot it as a histogram. I'm just going to set up my figure the same way. And this time I'm going to use the histogram function. So again, this plots the histogram on the left-hand axis, and this plots the histogram on the right-hand axis because I've specified AX1 and AX2. I've set some labels, and I'm just going to run that. And you can see this sort of final line actually saves this figure as an SVG, so I can bring it into, say, Adobe Illustrator. And there's the figure, and you can see that this file has appeared in my file structure. Okay, so let's say I want to work with these calculations in Excel, or I want to put them into a supplementary spreadsheet for a journal. What I can now do is I can save these calculations. So this uses VisiCal's Save Excel function. So again, we're saying save them sort of to my file, so that initial file you loaded in. And I want the new Excel sheet to be called andesite melt inclusion saturation pressures. And then here, I specify the calculations I want to save. So in this case, I want to save the Panda data frame calculated using magmasat and the one calculated using Dixon. And then I want the sheet names to be called magmasat and Dixon respectively. So again, Shift Enter. And again, that will appear in my file structure. Or I can just save a single set of calculations, and this is using Python's Panda function. So again, I just take the name of my data frame, say Iacone and Marziano this time, and then I say to Excel, and then the name of the Excel file I want. So I can run that as well. Now, so we have all this stuff saved on the server, but say we want to download it and get it on our PC. So we can just right click and say download. And let's do the same for that spreadsheet, just so I can show. And then again, you can just save this Python notebook, and it will stay here on the server. So let's open these up so you can just have a look. So what we have is the first sheet is just the data that you entered, sort of with these new columns appended for the elements that you didn't specify. And then we then have a tab for magmasat, which has all that data repeated, but then also, if I wrap text, you'll be able to see these a bit better. Has now the saturation pressures and any warnings you've triggered, and the same for Dixon. So we're going to save that. So that's a short introduction to running on the Enki server. And we'll make some more videos doing specific calculations in VisiCal.